Hey, hola! Or how about hello? Yay! Yes, and so many people say, Mr. Wara, you look a lot like that one comedian guy, Robin Williams, from Mrs. Doubtfire. Oh, yeah, sure, I am him. Hello! Okay. Hey, it's about time. Thought I'd try something new there. Oh my goodness, what do we have here? Look at it, it's a little owlet. Well, he's not so little. You're taking up my entire page. You're a big owlet. He's kind of cute. Look at these eyeballs. Hey, it's not nice to stare. Come on. Look at his little nose. All right. Hey. All right, I'm going to scold myself. Mr. Wara, come on. Supposed to be focused on our lesson. Okay. Look, we have the learning target. Could it be any larger? This is our objective of this lesson, is to relate decimal and fraction multiplication. Now, some of you may remember that, hey, Mr. O, we just did this. This was our last lesson. You know what? It was. But this is such an important concept, I guess we need to do it more than once. Anyway, let's go ahead and take a look down here. What do we have here? We have a language frame. We'll bring this thing up. A language frame here in this case says that my estimation of the product is reasonable because, okay, and we are going to use this today. I'm going to use it today, I should say. When I say we, I really mean me. Just kidding. The Grinch. Okay, so let's focus and let's get on to the next page. Bing. Hello, hey, woo. Look at him go, who, what? Oh, who, I get it. He's an owl. Who, yeah, very funny. Unless you're asking who, you spelled it wrong. Unless you want to know, I'm Mr. Wara, right? Yeah. You wondering who I am? Okay, I'm Mr. Wara, buddy. Okay, you just kind of kick back and see if you can just keep yourself out of trouble as we work out this problem. We have a problem up here. It does say 3.2 times 2.1. But first, let's do this. Let's go ahead like we did in the previous video. Let's rewrite our expression here of these two decimal, they call decimal fractions, but let's rewrite these decimals as a fraction multiplication here. So here I have 3.2. Wouldn't that be 32 over 10? We're just going to rewrite that. This is going to be 21 over 10, which is 32 tenths times 21 tenths. Now that I have my multiplication expression here, one thing I would like to do is I would like to be able to do an estimate. So let me look at my two decimals here. It looks like I have as an estimate, I'm going to say that's about 3. True, that means to be equivalent there. So I have about 3 times, looks like about 2. So it looks like I'd have an estimate about 6. That's just a rough guess of 6 is going to be my estimate. However, I'm wondering, is it going to be less or more than my actual answer, do you think? The actual product. Would 6 be less or more? And again, I'm thinking this number is going to be a little bit less because we actually rounded the number down a little bit. But it should be around 6, but my actual answer should be a little bit more than that. Now that we've estimated, let's go ahead and solve. Now, what do we get when we multiply tenths by tenths? That's right, we get hundredths. When we multiply tenths by tenths, we get hundredths. Question is, how many of them? We have 32 tenths times 21 tenths. Okay, we know this is the same as just rewriting this problem as 32 times 21 over 100. Okay, so now we just need to know what 32 times 21 is. Well, 32 times 21, we're going to go ahead and multiply our ones. Now we're going to go ahead and multiply our ones with the 3 tens up here. Placeholder. That's right, because we're going to be moving on to the tens place. 2 times 2 is 4. And then, of course, 3 times 2 is 6. I'm going to be adding these all together. Now I have 2, 7, 672. I'm going to go ahead and put my 672 over 100. Which in this case, you can see by looking at it, since we have hundreds here, that would be the same as writing it as 6.72. Because we're taking 672 and we're dividing by 100. And we know that when we divide by 100, that the decimal point moves 2 places to the left. Or if you wish, the digits move 2 places to the right. Same kind of thing. Right? Let's go ahead and write this in written form as well. So we actually had 32 tenths. We had that times 21 tenths. Now we know it equals, let's put that down here, 672 hundredths, which is equal to 6.72. That's basically what we did. In our work here, we did our 32 times 21. Okay, we'll go ahead and do this here. And I just wanted you to see that our tenths and our tenths, when we multiply them, actually gave us hundreds. So the bigger question becomes, does this answer make sense given what we estimated the product to be earlier? Well, we did. We estimated the product to be 6. We did say that our actual product should be a little bit more than that. And look at that. It is a little bit more than that. Okay, let's do another problem. What's this? Who's Mr. Wara? I just told you I'm Mr. Wara, you little outlet. Oh my goodness, you're funny. Funny! Okay, I'm just, if you weren't so little right now, you might end up in a recycling can. But you know what? I'm looking at you. You're kind of small. All right. I have some compassion for you, even if you do regurgitate your food. Anyway, back to the problem. Yes, now we have 3.2 times 0.44, 44 hundredths. We want to go ahead and do an estimate here first. 3.2, in this case, basically taking, looks like 3 copies of about a half. If you see that, 0.44 is almost a half. So that's like 3 halves. So our answer would be probably around maybe 1.5. So I'm just going to put my estimate at about 1.5 because I'm looking at that 3.5. Okay, you get the idea there. Now this is also about 3 times more than 4 tenths. So the answer should be around 12 tenths. Now it will be a little more because the 3.2 is a little more than 3 times as much when we were doing our estimate here. So let's go ahead and rewrite our problem as a fraction. This would be 32 tenths times, we have 44 over 100 or 44 hundredths. What is 1/10 of a hundredth? That's right, it's going to be 1,000th. So let's go ahead and multiply our 32. Now remember, this is tenths now. And here we have 44. That's hundreds. Okay, we're going to go ahead and solve this. 8. Then we have 12. Placeholder. Okay, and then we have 8. And then we have 12. We're going to add these together. Now we end up with 3, 4. Looks like 1,408. We had tenths here and we had hundreds here. But with our tenths and our hundreds, that's actually going to give us thousands. Well, thousands, then that means that decimal place is going to move 3 places to the left. See, 1, 2, 3. So we put that decimal place there. Now it becomes 1 and 408 thousandths. So now we can go ahead and keep showing this in fraction. So this would be the same as 32 times 44, okay, over 1,000. We already determined that was 1,408 over 1,000. And just like we divided, this gave us our 1.408 or 1 in 408 thousandths. Okay, again, we're relating the decimal and the fraction multiplication. And again, we ask that question, is my answer reasonable? Well, my answer is very reasonable. If you look at the 1 in 408, 1 in 408 thousandths, it's really close to 1.5, 1.5. So let's go back and look at our language frame. See, our language frame here said my estimation of the product is reasonable because my actual answer was close or extremely close to my actual estimation. So in this case, we had estimated, remember, at 1.5, and we ended up with an answer of 1 in 408 thousandths. And so that's reasonable. And the purpose of this language frame is, again, to use those words helps us solidify and get a good understanding of our math concept. So here's the problem again, which we finished up. Now let's go ahead and do another problem. Now I think what I'm going to do, what? You go from who's Mr. Now you're going what? Okay, you know what? I think you need some ears. Okay? I mean, listen to the sound coming. Okay, you little owlet. Oh my goodness, you're kind of getting on my nerves now. Anyway, Mr. Owlet, we're just going to let you sit there. I'm going to pretend like you didn't say what. All right. Now on this one here, what I will do is I'm going to go ahead and solve this problem like I have with the other ones. However, like before, I would encourage you to try this one on your own first and put the video on pause and see if you were able to solve it and that your results match up with mine. Okay, here we go. So you see how you did? Hopefully you got your 13 and 472 thousandths. In this case, we made our estimation. Are we close? Yes, our actual estimation was a little bit lower as I expected it would be. It's a little bit higher here. What we also did too, we expressed our answer as a fraction and a decimal. So just when I wrote here equal to, that the 13,472 over 1,000 was equal to 13 and 472 thousandths. Okay, here. So these were represented as a fraction and a decimal. All right, let's go to the next page. Cruising along. Yeah. Okay. All right, buddy. What's up with that now? Where? Really? You're going to do the who, what, where? Aren't you funny? Ha ha. You're so funny. Yeah. How would you like some? Yeah. How would you like some like little bloodshot eyes? Are you up too late? Uh huh. Looking for some moles or something there? Yeah. Where? Right here. Okay. All right. Mr. Wara, you're letting that little owl get to you. I know. I just gotta let it go. Let it go. No. Okay. So problem two here, we have 2 and 6/10, and we have a little measly 4/10, like we've always done. First thing is I would have to say, well, how many tenths are there in 2.6? 26, aren't there? 26 tenths. When we think of this time, I want to think, what does tenths times tenths result in? That's right, it's going to equal hundreds, right? So our product will be named in hundreds. So what is 26 times 4? Well, yeah, let's go ahead and figure that out. 26 times 4 is 4, carry the 2, 8 plus 2 is 10. 104. 104 what? What is our unit here? Oh, that's right. We said it was hundreds, recall? If I remove that decimal 2 places, then I get 1 and 4 hundredths. Now, let's go ahead and use fraction multiplication as a way of confirming that this indeed is our product. So I'm going to go ahead and take the 2.6 and make that 26 tenths times, and then we have 4 tenths. Okay, go ahead and rewrite this as, now that we know 26 times 4 is 104, but let's do this here first because I want you to make sure that you see that this means the same thing as that. And then of course we have our 104 over, here we have 100, and yes, look at that. We have 104 hundredths. That's what we have here. So that is equal to 1 and 4 hundredths. Don't you just love when things come together? Yeah, I like that. Let's do more. Yeah. And then hopefully you'll just find a way to, I don't know. Oh, what? You have measles now? Oh, I'm so sorry. I'm sorry. That's how it goes. That's what you get for eating your food live. Anyway, that pretty much solved that one. I think it's time for another problem. I was afraid to turn the page here. What are you going to say now, huh? Probably going to say something like that, isn't he? There you go. You don't ever stop, do you? When? Oh my goodness. I'm going to make you turn a different color here. You're going to see. Wait. All right. 3.1 times 1.4. Well, let's go ahead and estimate our product again. 3 times, looks like 1.4. I don't know. We're going to say that that's 1. I could. It should be something close to 3 times 1. Something between maybe 3 and 6 because 1.4 is almost at the midpoint. So let's say 3. And then, but it's close to 3 times 1.5 really when you think about it. And that's 4.5. So maybe we want to do a little product of 4.5. Did that make sense to you? This is about 1.5 times 3. So we kind of think 1.5, 1.5, 1.5. That's closer to 4.5. All right. So let's go ahead and use a unit form like we did the last time. My multiplication expression should be 31 tenths times 14 tenths. What's our product going to be here? Well, we know we're going to get hundreds. So let's go ahead and multiply that through. Keeping in mind these units are tenths. 4. Looks like a 12 placeholder. Okay, and then I have 1, and then I have 3. Then I'm just going to add these together and get 434. But again, remember this is hundreds. Nice. Which means I move that decimal place 2 places to the left, or I could have moved my digits to the right, but that would have been difficult here without my place value chart to do that. Anyway, all the same, if you know what I mean. So if we were to go ahead and want to confirm our product, we could say our 31 tenths times 14 tenths, okay, is going to be equal to our 31 times 14 over 10 times 10, which we already learned was 434 over 100. And yes, that does equal 4 and 34 hundredths. Yeah, man, we're making this stuff look easy. That was easy. Yes, okay, let's turn the page. Buddy, I'm warning you. All right. You're probably going to say, what did he do? What? Where? When? Now he's probably going to say why, right? Who? Really? You're going to go back to who? Oh boy. Sorry, I'm just trying to stay cool with the little owlet guy. I know. Surely you guys think I should be able to do something with him. I don't know. I just don't have a recycling can. I think I'd put him in it though. I see your chicken pox cleared up. That's nice. Or was it the measles? I don't remember. But you had some pretty funny looking red dots on your face. Okay, focus. We have 31 hundredths times 1 and 4 tenths. Okie dokie. Let's think of 31 hundredths and 1 and 4 tenths as whole numbers of units. Did this on that last problem. 31 hundredths. That wasn't very hard. Ooh, look at that cool D. Ooh, he's happening. Surf's up, dude. All right. And then 14 tenths, right? Because 1 and 4 tenths is the same as 14 tenths. We're basically saying this and that. I know some of this is a review. So if we were using fractions to multiply these two numbers, is 31 times 14 the numerator or denominator? Well, that's a good question. Yeah, I think you guys are thinking that's the numerator. That's the number we've been putting on top. So what does the numerator of a fraction tell us? Well, the numerator, it tells us basically the number of units that we have. So this whole number multiplication problem is the same as our last one when you think about it. So what is 31 times 14? Well, didn't we figure that out already? Wasn't that 434? Is that what the last problem was? Let's take a look. It sure was. We did 31 times 14 and we ended up with 434 hundredths. So let's go ahead and use that number. And in this case, because we have hundreds and we have tenths, then that means we're going to have 434 thousandths. Digits are the same, but we have a different unit this time. See, the last time we had a total of 2 decimal places in our factors. So we had 2 decimal places in the product. But this time, notice that there are a total of 3. Here's 2 and there's 3. So there's 3 decimal places in the factor. So we're going to have thousandths as our actual unit. So our product will be 434 thousandths. Just remember that 1/100th and 1/10th gives us the unit of 1,000th. Okay, the denominator of our fraction. Okay, I think on that one there, we're going to go ahead and move on. I'm warning you. Oh, now he says why. Hoo 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 hoo. You're a poor little fella. You know what you just need? You just need a good education. That's right. It's a good thing you're paying attention here. See, I'm trying to turn this into the positive. You're actually pretty nice, I think. Yeah, so just keep watching because you're having some challenges, should we say. Okay, for this last problem, we're going to go ahead and we'll work independently. You can put the video on pause. That way you can go ahead and solve this. What I want you to do is you can decide, solve this problem using either the unit form that we did, or you want to go ahead and do the fraction form, whatever's easiest for you. When you're done, just go ahead and make sure you count the decimal places in both factors and then put those decimal places in the product. All right? Here we go. Yay, Mr. Owlet, time to say goodbye to you, huh? Yeah. Goodbye. Yep. No! You know, this is a lesson in patience and tolerance, my friends. Okay. All right, you called all your buddies. Fine. But you want to know something? That's right. It's that wonderful time where we have to say, live long and prosper.